అందరికీ నమస్కారం. My name is Ashwin, and today we are going to do some trigonometry. Now, for those who don't know, trigonometry is a branch of mathematics which deals with lengths, angles, and basically triangles. Now, angles are a very integral and important part of trigonometry. So, to do any trigonometry, we basically need a way to measure angles. Now, to do that, I have made this contraption. It's nothing but a protractor, a coiled up paper in a cylindrical form, and a thread and a safety pin for weight, though you can use a better weight if you want to make this. So basically, this which I'll be calling Urdhva Suchi, or an measurer of the angle of elevation. Anyway, you'll get to know how to use this later in the video. But first, for our experiment, let's find out the height of the building that I am in. To find out the height of the building, I have taken my Urdhva Suchi and have come to a balcony. Here, let's find a spot that I can walk to here. Now, to take that point that I can walk to, let's take the black bike that's over there. The quality is not that good, but bear with me. I'm sorry. Now that we found out the spot that I can walk to, let's take this Suchi and measure the angle of depression. So to do that, first take this and bend over till you find the bike in your field of view. Yes, now it's in, and the angle of depression is approximately 55 degrees. Now, if you're wondering, this is how it should look like if you yourself are going to see. Look, there's the bike at exactly the center of the paper. Now, some of you might be wondering, why are we doing all of this? Let me show you. Now, let's first assume that this is the ground floor, okay? And this is the building, which is correctly 90 degrees, exactly 90 degrees to the ground, basically perpendicular to the ground. And I am here at the 11th floor, okay? And here is our bike, and this is my field of view. So if you assume that I am standing at point A, this point exactly beneath where I am standing is point B, and the point that the bike is point C. This is nothing but triangle ABC, which happens to be a right angle triangle, meaning we can use our trigonometric formulas here. Now, for the sake of simplicity, let A and B, which is the height, be h, represented by h, and the length BC be represented by distance, which is b. Okay. Now, this is AB, which is height h, which we have to find, and D, which we can measure by just going down. So let's go down. Here, this point is approximately below the point that I was at right now. Now, to measure the length of the line BC, let's first count the number of tiles in the line BC. So, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 97, 98, 99, 100, 101, 102, 103, and 104. And here's a black bike. Now I've already previously measured the length of the tile. So a single tile is 38 centimeters in length. And we also know that there are 104 tiles between B and C. So the 104 tiles and 38 centimeter per tile. So the total distance in centimeters can be found out by simply multiplying 104 and 38, which is equal to 3952 centimeters. So 3952 centimeters. Now, to find that out in meters, because centimeters is really impractical. So in meters, it would be 3952 divided by 100. So 39.52 meters. So the distance D is equal to 39.52 meters. Here we know that the angle of depression, which is this angle, is 55 degrees. But we actually only need this angle, right? So to find out this, all we have to do is just subtract 55 from 90. So 90 minus 55, which is equal to 45. 35, sorry, 35. 35. From this point, it's just really very simple. Now we know that this angle A, angle CAB, is equal to 35 degrees, and we also know D, which is 39.52 meters. So, and we also need to find H. To do that, it's very simple. Now from this, we can clearly see that tan of angle A is equal to opposite, which is distance D, divided by adjacent, which is height H. So in this case, A, which is CAB, is 35 degrees. So tan 35 is equal to distance, which is 39.52 divided by H. That's what we have to find, height H. Now the value of tan theta is, tan 35 is approximately 0.7. So if we substitute that in place, 0.7 is equal to 39.52 divided by H. And we know that H is equal to 39.52 divided by 0.7. Now if we simplify that, it comes down to approximately 56.4 meters. So the height of the building, which is H, is approximately equal to 56.4 meters. Now, some of you might ask, couldn't we have just use the Newton's laws of motion? Like, let's just drop one item at the 11th floor and map the time t it took down to fall down, and use the formula S is equal to ut plus half gt square. No, actually, since u is 0, it would just be half gt square. Half gt square. Well, yes, that's actually kind of true, but the issue is that with this amount of height, there's bound to be a lot of air resistance. Meaning, the time taken due to the resistance, the upward resistance of air, the time taken will increase. And if the time taken increases, since the displacement, which is nothing but height h will be directly proportional to t square. Which basically means that if time increases, then the height calculated will also increase. And if it increases, it will be a lot more than 56.4. So, which is not really ideal. So, of course, if we were able to calculate the air resistance as well, we can easily measure it out using Newton's formulas, which is a much more straightforward method. Of course, beside calculating the air resistance part, it is a much more straightforward method. But this trigonometric way basically has no constraints. The only constraint being the accuracy and precision of your measuring instruments. Aside that, this trigonometry is basically flawless. The trigonometric method is basically flawless. Well, I guess that's it for today's video then. Let's meet in another video. If you liked it, please like, share, and subscribe. I'll meet you on in the next video. Bye bye.